piece, see if you guys remember this without looking down at your paper. If I ask you what a line is, line AB, what does that mean? So we have an A, we have a B. Does it stop?
No.
No. Keeps going both directions. Notation for that, AB with this line symbol over the top. If I ask you for a line segment, how is that different?
It's AB and it stops.
Notation for that is an AB with just a segment drawn across the top. Does it matter if I put the B over here and the A over here? No, with lines and line segments, the order of those letters doesn't matter. How is array different? So if I write AB with a ray symbol over it, we have point A, we have point B. Which direction does it continue? Through B. Is that the same as array, let's say if I put the B here and the A here?
No.
How would I write that one?
BA.
With that symbol. Okay. I am not going to specifically test you over this. I'm not going to ask you for the definition of line or anything on a test. Really, I'm just trying to refresh your memory on some of the notation. So if I talk about a line or array or a segment, you kind of know what I'm talking about. It's also a good review if you haven't had geometry for a while. If you're taking an ACT or something, just kind of hit some of these things. With trig, we are going to be dealing with angles. An angle is formed when you put two rays together with a common endpoint. So here's a ray, here's a ray. They have the same endpoint, so they form an angle. When we talk about this, I might ask you about the sides of the angle. The sides are these two rays. So this is a side, and this is a side. What's the vertex? Yeah, the vertex is this point they have in common. Okay. The difference in geometry, you have this stuff, but what we are going to be doing when we talk about angles is you will see an arrow drawn on the inside of our angle. And this arrow is going to be very important for a few things. First of all, we're going to talk about positive versus negative angles, and the direction of that arrow determines if it's positive or negative. Second of all, it'll show us if we're talking about the angle in between these two rays, or if I'm talking about the angle that falls outside them. So we will be drawing that every time we draw an angle. This helps us differentiate between the two sides. We have what's called an initial side and a terminal side. So an angle is formed when you take one ray and you basically spin it. So if I'm looking at this, which would have been my initial side or my starting side? Yeah, this one. And then I'm spinning this side up here and stopping. So this is what's called my terminal side. So initial is just the beginning, the terminal is the ending. And that arrow determines what's the initial and the terminal. If I drew my angle like this, where is my initial side? Top. And my terminal side is down here. Are we okay on the difference between initial and terminal sides? talk about how to tell if an angle has a positive or a negative measure. I'm going to draw a couple pictures here. Here are two angles. These angles have something in common. What is it? Look at that arrow. In both of these, the measure is positive because the arrow spins counterclockwise. So it doesn't matter if it's inside or outside, you're looking at the direction it's turning. So counterclockwise is the positive direction. So if I drew my angles like this, how's my arrow spinning in those? Clockwise. Those are negative angles. So it all depends on where that arrow is drawn when you look at your measurement and try to decide if it's positive or negative. Any questions so far? Without reading on the paper, let's see what we remember. What is an acute angle? So something like this would be an acute angle. The measure is, you said, less than 90. We have to be a little careful because now that we're talking about negative angles, we don't really want to, we need to be careful. You know, negative 120 degrees doesn't necessarily mean it's obtuse. So we're going to say it just measures between 0 and 90 degrees. And we'll talk about if we have a negative angle, how to make it a positive angle so we can decide. What's a right angle? 90 degrees. And we know that a right angle looks like that. You see the little box in the corner that tells you it is a right angle. What's obtuse? So we're going to be a little more precise. Instead of just saying bigger than 90, we're going to say between 90 and 180. And what's a straight angle? A straight line, which is 180 degrees. Remember all those terms, hopefully? What about complement and supplement? So complementary, two or more angles that add up to 90 degrees. Supplementary, two or more angles that add to 180. Sometimes I have people that mix up the two of those. So when I look at the first letter, think alphabetical order, C comes first, so that's the smallest one. So complement is the 90, supplement is the 180. All right. Here's a problem. Does anybody want to come up and work it? Thank you, Bo. You'll have to do it on the dry erase board because the program I wrote these slides in, my TV doesn't like it and you can't write on it. It doesn't matter, you don't have to. All right. So which is which? Which one's complement and which one's supplement? Good. So on, homework test quiz, you can leave it, it's fine. So you would have to make sure you label which is which. So supplementary is the 180, complimentary is the 90. So the supplement is 125 and complement is 35. Second thing, I would like for you to get in the habit of putting your degree symbol. Right now, it's not a huge deal, but in a few chapters, we are going to learn another measurement for angles, and we'll do what's called Radian Measure. And at that point, anytime you don't have a unit written, it's assumed to be radians. So right now, I know you mean degrees, but later on, there's a huge difference between 55 degrees and 55 radians. And if you don't have the measure, we'll assume you mean radians. So get in that habit of putting your degree symbol on your answers. Anyone want to work this one? What would we do here? What we did is said, okay, this right angle symbol means they add up to 90. So if you do 2r plus 3r, you get 90. You can put your degree symbol on everything within the problem, but you have to have it at the end. So if you don't put it on your work and you just put it on the end, that's okay. But, am I completely done? I asked for the measure of each angle. So 2r, 2 times 18 would be 36 degrees, and 3 times 18 is 54 degrees. You can do a quick check, those two add up to 90, so we don't have any mistakes. Okay. What about this one? So these two make a straight line. We know that's 180 degrees. So we added those together and got t to be 20. So to answer the question, 7 times 20 is 140, and 2 times 20 is 40 degrees. So far, so good? A notation thing. In trig, you will find that for variables, a lot of times they use Greek letters. So you're used to x, y, and z, but then we start throwing alphas and betas and thetas and all of these things at you. It's no different, just means a variable. So a very common one that we'll start with is this symbol. That's called a theta. It's just a Greek letter. If I'm talking about the measure of an angle, so whether that's angle A or angle theta or anything like that, the notation that we use is lowercase m for measure. Then we do this angle symbol, and then we write the name of the angle. So you might say, measure of angle theta equals 12 degrees or something like that. So just know, anytime you see that lowercase m in front, I'm asking you to find the measure of that angle. All right. Now, we can measure angles in degrees, but sometimes we need to be more accurate than that. If you ever look at a property description, like a legal description of a piece of property, and it tells you the location of that property, it doesn't just say 17 degrees north. It says 17 degrees, 5 minutes, 13 seconds north, because it's got to be precise. If you're working for the military and you're going to fire a missile, you don't want to say, that's about 15 degrees, and hope that it lands in the right spot. You have to sometimes be more precise than that. So we can use decimal degrees, but a more common notation is what's called degrees, minutes, and seconds. And so we will see that a lot. we already know that for degrees, we put the little degree symbol. The notation for minutes is 1 tick mark, and seconds is 2 tick marks. Now after this, it works just like time. Okay, if you just replace hours with degrees, we've got it. So we know if we're talking about time, if I write this, 1 tick mark means minutes, so that's saying 60 minutes. 60 minutes is how long? 1 hour. But we're going to replace hours with degrees. So 60 minutes is equal to 1 degree. Alright, we know that if we have 60 seconds, so 60 with the 2 tick marks, that's equal to what? Okay, so it's not really anything new if you just think about the clock. You replace your hours with your degrees. So the first thing that we need to do is get comfortable with dealing with these numbers. So we are going to add and subtract with them. Okay. So if I asked you to do 28 degrees, 35 minutes, plus 63 degrees, 52 minutes, what we're going to do is set it up like you set up your addition problems when you first learned how to add big numbers. You stack them, right? And then we're going to do just like we always do if we add or subtract. We always add and subtract like terms. So we're going to add our minutes together, and then we will add our degrees together. So for the minutes, 35 minutes plus 52 minutes. For the degrees, 28 degrees plus 63 degrees. So let me ask you a question. If you're giving directions to somebody and you say, okay, it's about an hour and 87 minutes away, would you say that? Why?
Because you just round it up and it's not practical.
Right.
You have to think how much an hour is in minutes.
Anytime you get more than 60 minutes, you turn that into an hour, right? So here, if my minutes are more than 60, we will turn that into a degree. So essentially what we're going to do is take away 60 of those minutes and add 1 degree instead. So I would get 92 degrees and 27 minutes. Does everyone understand what I did right there? You won't have to do this every time you add, but if you are adding these things, you want to double check at the end. If your minutes are bigger than 60, take 60 of those and move it over to your degrees. Likewise, I didn't have seconds, but if I had, let's say I said you have 30 seconds and 50 seconds. That would have given me 80 seconds. So then what would you need to do with your seconds? Right. You would take away 60 of those and turn it into a minute. And so we would have 28 minutes and you took 20 seconds. Okay, so whether your minutes or your seconds turn out to be bigger than 60, that's the only time you have to do that. Let's look at a subtraction problem. 180 degrees minus 117 degrees, 29 minutes. I don't have any minutes here, so if you want, you could write a 0. So think back when you first learned how to subtract. Can you do 0 minus 29? So what did we do instead? Borrow. Okay. If I take away 1 degree, so that would leave me with 179 degrees, that 1 degree turns into how many minutes? 60. So I bring over 60 minutes instead. Do you guys agree? 179 degrees, 60 minutes is the same thing as 180 degrees. We just rewrote. So now you can subtract. Again, we do like terms. So we do minutes minus minutes and degrees minus degrees. So 60 minus 29. 179 minus 117. Do we have to do anything special like we did on the last one? No. So that's our answer. You guys try a couple. So the first one, if you add your minutes, 29 plus 57 is 86. 51 plus 21 is 72. Are we done? No. Take 60 of those minutes and move it to a degree, so you get 73 degrees, 26 minutes. B, we have 120 degrees minus 101 degrees, 4 minutes. Your textbook will write it as 0.4. I don't care, that's not necessary, so you don't have to do that. So we have to borrow, so it would be 119 degrees and 60 minutes. So 60 minus 4 is 56. 119 minus 101 is 18. So 18 degrees, 56 minutes. Alright. So far, so good? Alright, the next little part is going to take me just a little bit to explain. So I think I'm actually going to stop here today. So we're about halfway done, maybe a little over half. Tomorrow we will wrap up this section. What I want to do today, I'm going to go ahead and give you a few problems. They're not really technically homework. Tomorrow I will finish this section and then you'll have some more time to work. But since we do have a little time right now, I don't want you just wasting it, so you might as well get started. So these problems, I believe we've gone over how to do all of them. If you would like to work with a partner, you may do so. So there's 8 problems and you've got